So wow, this is beyond crazy. I don't even really know how I feel about giving you the information this way. This is an AP class. It's a hard class. It's a hard class to understand. But this is what we have, and we're going to make the best of it. I'm going to do my best. I realize this is many of your senior year. I'm going to do the best job I can getting the information that you need. Please understand that the teachers here really care about you, really love you, and we hope to connect with you the best we can. It's going to be an exciting adventure. I'm nervous about it. I think that this is probably good for me because, as you know, I don't like to Instaface or snap a tweet or snap a chat or any of that stuff. It's just not who I am. So the fact I'm posting videos online on a subject like AP stats is a step outside the box for me. So I don't know. I use all my time whenever I teach. So the math will be there, and I'm going to get cracking on it right away. My goal would be to keep these videos as short as I can. I don't want them long and drawn out. Some of the parts of videos will be you pressing pause and actually reading in the book, and that would be an expectation that you do that. Much of the discussion that we would have had in class now will be contained in the reading. In fact, many discussion pieces, when we have class time, many discussion pieces come right out of the book. So you need to understand that in order to fully get the material, you're going to have to do some reading. I'm going to try to keep the reading pieces short. I know the stats book isn't exactly a page turner at times, unless you're really into math. So we'll do the best we can, and we'll go from there. So your first assignment, you're going to press pause right now, and I'm just going to start back with chapter 10.1. I know last week was a crazy week with everything going on, the musical, the power outages, the just upheaval. So I'm going to start back in chapter 10.1, and we're going to just kind of hit reset. You'll have some assignments that you turn in daily after you read and do what I ask you to do. But right now, what I'd like you to do is I'd like you to pause the video, read pages 621 through 623 in your book. It's about conditions of subtracting proportions, and then we'll get into it. So hit pause now and go ahead and do that. Okay, hopefully you've had a chance to read Comparing Two Proportions. I have the information down here. This is the information contained within the book. And when you're comparing two proportions, it's not unlike what we've done before when we compare proportions. The conditions are similar. They're still unbiased estimators. They're still standard deviations. The only difference is you're looking at taking two separate proportions and you're going to subtract their values. And if certain things happen, you can tell what the shape is, you can tell the mean, the standard deviation. But really the first part that I'm going to have you concentrate on are just the conditions that allow you to subtract proportions, that allow you to tell what the sampling distribution has, what shape it really has. And that's 1, 2, and 3 that you're looking at here. So first of all, if you subtract proportions, the sampling distribution, you can tell it's approximately normal if, and because there's two proportions, you have to check conditions for both sets of proportions. So for here, it's NP1 is greater than or equal to 10, and so on, and you can read those, and basically that tells you that if these conditions happen, you're going to have a normal shape, and you can do Z conditions, you can do Z calculations as you go through. And that section really isn't anything, that number one really isn't anything but telling you, hey, this is what the shape's going to be like if these things happen. Number two, I would expect this to happen. The center of the mean of the difference of the proportional values that you found should center around the true population proportions. So we say sample means are an unbiased estimator. Basically, the proportional values that you found, if you subtract them, you should get the actual population proportions. Again, we use the term unbiased estimator.
And last but not least, the standard deviations can be found if the 10% rule applies for both. N1 is less than or equal to 10% of the population, and N2 is less than or equal to 10% of the population. And when that happens, your standard deviation can be found with the following formula. And you can kind of see that, and you might notice within that square root, P1, 1 minus P1 over N, that's a situation that we've seen before. We're just adding to it a second population proportion. And what this is going to tell us is how much the difference in the sample proportions would typically vary if we took many, many samples. What would your typical standard deviation look like? And with that, we're going to do alternative examples. We're going to tackle grade level and gender. Now, what I'm going to have you do with this grade level and gender sheet, and this is in your alternative examples, what I'll eventually have you do is I will have you take a picture of this and do a submission. We'll still have a quiz at the end of this 10.1, but right now we're working on this. When you're done, snapshot and give it to me. So first of all, it says, in a very large high school, the junior class has 800 students, 54% of whom are female. The senior class has 700 students, 49% of whom are female. The student council selects a random sample of 40 juniors and a separate random sample of 35 juniors. So that's your difference in proportions. You have two samples. Let P hat junior minus P hat senior be the difference in sample proportion of females, and it asks for the shape. And the shape is approximately normal if these happen. So we want to check to see if it's approximately normal. And what I would do here is I would use that NJ, PJ, with the J being your juniors. And I would check the population. So we're going to check that, and then it'll be NJ, and then 1 minus PJ. And I'm going to check both of those. And then likewise, it'll be number of seniors sampled times your P of your seniors, and then NS1 minus PS. And that's really what you're going to do. So NJ, number of seniors, or number of juniors that we sampled, we had 40 of those. And that proportion of females in a very large high school junior class has 800 students, 54% are female. So I'm going to have 54% here. And then that'll be 40, 40 times 1 minus the 0.54. And we do that math, and we see what we get. And I got 21.6 here when I did the math, and I got 18.4 here when I did the math. You guys press pause and try the second one. Okay, so now what I'm going to do here on the second one is I'm going to take the number of seniors sampled, which was 35, times their proportion, which was 0.49. And then I'm going to take 35 times 1 minus 0.49. And hopefully we were able to do that and get 17.15 and 17.85. Now, I didn't put what was supposed to happen with these, but the essence of it is this. If all of these values are greater than 10, this condition is satisfied, and what we have is we have a normal shape. So I'm just going to put that down, normal shape. Okay, part B, find the mean of the sampling distribution. Well, the mean is an unbiased estimator. The mean of juniors, proportion of juniors, the mean of the proportion of juniors minus the mean of the proportion of seniors. Well, my proportion of juniors who were female was the 0.54, minus the proportion of seniors was 0.49, and I got a 0.05 mean of the sampling distribution. What that means is if you subtracted the proportions, what would you most likely get? 0.05, and that should center around the actual proportion. Last one, calculate and interpret the standard deviation of the sampling distribution. Well, in order to do that, we first have to check these conditions again. So I'm going to go N1 compare it to 10% of the population, and N2 compare that. So on the juniors, I guess the first thing I should check always is it a SRS, and it does say it was a simple random sample. And now I'm going to check, is 40 less than 10% of all? 10% of all, and it says large high school, so we would make the assumption that yes. And then my seniors was an SRS, and then 35 is less than 10% of all, and we have that right now. So since those conditions are met, we can proceed with the standard deviation. So standard deviation of the expected proportion minus the expected proportion is going to be equal to the square root of 0.54, 1 minus 0.54 over 40, plus 0.49 times 1 minus 0.49 all over 35. And what I'm going to have you do is I'm going to have you calculate that and write it down. What does this mean? This means the junior minus senior difference in sample proportions of females generally varies by that amount. You need to fill that amount in the blank from the difference of varies by that from the difference of 0.05. So we can tell how much our typical difference would vary, and there's something pretty significant about that number, and the fact that that number is over 0.05 brings 0 into the conversation on the backside of the standard deviation, which we'll talk more about this later, but the fact that 0's in that interval 1 standard deviation away says there might not be a difference at all in these. Okay, what I want you to do next, I want you to pause the video, and I want you to look at the conditions for the confidence interval right here. I want you to read those in the book, 623 through, let me see here, 623 through 625. Do that for me, and then after you read that, we will talk about the conditions. Okay, the conditions for a confidence interval. We're going to actually create a confidence interval tomorrow in the next video. And the confidence interval is, if I subtract the proportions, what would I generally expect that value to be in? What's a range of values that would most likely happen? We'll say we're 95% confident that such and such is going to happen, just like we have in the past. But in order to create that confidence interval, again, we have to have conditions, and these conditions we'll have to state each time as we go through a problem. And it actually makes more sense as you do a whole out problem. It will make more sense, and we will relate this back to our junior high problem that we did. So the conditions: data comes from 2 independent SRSs or 2 groups in a large random experiment. The large counts condition works for both. We've seen that situation before, and we've seen that situation. The 10% condition works for both in order for us to do our standard deviation. All of these things have to happen in order for us to make a confidence interval. So having said that, we're back over here for the last part of this, Nike or Adidas. The problem is a student project tried to determine if males and females have the same brand preference between Nike and Adidas. The students took random samples of 40 females and 30 males from a large high school and asked them if they prefer Nike or Adidas. Of the females, 55% preferred Nike compared to 80% of the males who preferred Nike. Let P of F, true proportion of females who prefer Nike over Adidas. P of M, true proportion of males who prefer Nike over Adidas. Check if the conditions for calculating confidence interval are met. So we're going to do conditions for proportion females, and we're going to do conditions for proportion males, and we'll have it. So first of all, students separate random samples of SRS checks off for both. Let's check the 10% condition. The 10% condition is pretty easy. Is 40 less than 10% of all at the large high school? I think it says large high school. No, this one isn't even large high school. Oh yeah, large high school. I'm assuming 40 would be less than 10% of all at a large high school, and 10% here, that was 30 of the males, is less than 10% of all at this large high school. And then we're getting into whether or not we can find that standard deviation, whether the standard deviation works for this case. And I'm going to take 40 times the stated proportion for females, which is 0.55. And then I'm going to take 40 times 1 minus 0.55. And then I'm going to take 30 times the 80% of males. And then 30 times 1 minus the 80% for males. And it turns out that there's a condition on here that actually is not met. So I'm going to put not met, and what I would like you to do to finish this off is I would like you to circle and write a statement as to which one of these conditions right here you think did not get met that would not allow us to actually do a confidence interval. When we meet tomorrow, I'm going to start talking about the confidence interval, and we'll actually start developing the confidence interval. What I would like you to do with this is when you're done, take a picture of it and submit it through Canvas. Thank you, and we'll see you tomorrow.